Good morning, good afternoon, everyone. My name is Ibrahim Hamza. I work for Microsoft, and I'm the data and AI go-to-market leader covering all of Asia. And I'm excited to welcome everyone to our first edition of AI Horizons. Now, AI Horizons, it's a new series that we've launched within Microsoft, really focusing on our real cutting edge AI technology and our AI scenarios that's really going to help you kind of spark your imagination around what is actually possible with the latest and greatest technology coming from Microsoft around artificial intelligence. This is a chance for you to look at some of our latest thinking. We're going to share with you some of our rapid learnings around AI, learn from other kind of early adopters from our technologies across Asia, and help you innovate using AI a whole lot faster. Now, who do we expect is going to be on a call like this today? Really anyone who's a technology enthusiast. We're thinking of CXOs, anyone who's making AI decisions, any AI digital or product leaders, and really anybody who's using the technology today as an early adopter or an enthusiast who cares a lot about what's happening in the world of artificial intelligence. Now, we've got a lot that we're going to cover today, and I'm really excited first to cover a bit of the news. What are the things that we're most excited about that we see happening in the world of AI? And then we've got two deep dive sessions. Number one, we're going to talk about the world of AI agents. We know that that is certainly an area that people are excited about today, and we're going to walk through what we're seeing in the world of agents. And then number two, we're going to talk a little bit about AI reasoning models and a little bit more about the O1 model that I'm sure many people have heard about already. We're going to go through a lot of demos, we're going to show a lot of use cases, and we're going to hear from two of our experts here at Microsoft. Now, I'm going to go through and walk through the agenda for today. Now we've got two of our experts from Microsoft joining us. We've got Luca and Rafael, and they're from our team called the Global Black Belts. And they are some of our greatest experts here at Microsoft who really go deep and understand the technology and how it's being used. So we'll go through the news first, and I'll invite Luca to help walk us through some of the things that he sees are most exciting in the AI space. We'll go through reasoning, agents, and then we'll have a little bit of a next steps discussion myself. So with that, I want to bring Luca into the conversation. Luca, I'd love to hear from you a little bit more about what gets you excited in the world of AI as we come into the new year.
Yeah, thanks, Ibs. I think there's three areas that I really think are going to be the forefront of what we see in 2025. And that comes to data and different modalities, embodied artificial intelligence, like robots, and the self-improving AI as we head towards AGI. And I thought I'd just put a few examples to sort of put some color around those fields. So the first one being data. And we talk about how you might have heard people say we're running out of data. We've trained the models on all of the internet. So where will data come from going forward? And I really see it coming from video data, from things like audio data, and as well as things like these generative environments. Like in the top right, that was actually me playing playing Minecraft, but it's not actually a video game engine. It's actually a generative AI world where I can control it and walk around, and each frame is generated by AI. And this is really useful. And you can see in the bottom example there, something called Genie 2. It's actually being used to generate these synthetic worlds to help train agents. So all these different places where we're going to go looking for data to keep training these models. The second one I mentioned was embodied intelligence, and it's how we actually give AI the ability to interact with the world around us. And what you can see here is a lot of the time we're spending time training robots in simulations. That's in the top left. And then in the top right, you can see we can take those simulations with these AIs have never seen the real world, and yet they can run around and actually be deployed to a robot and start moving about. So how we can actually give these models the ability to walk. Similarly, we've got humanoid robots. You would have seen a lot of advancements in this area with things like Optimus, X-Hand Neo, and there's so many coming out at the moment. The ability for these, what were large language models, now we say foundation models, how they can actually interact and see the world is really unlocking some of the new capabilities for these robots. And lastly, one of the things that I really think is so interesting as we look forward is we're talking about agents today. Raf's going to take us through that. So examples of how agents interact. We look at things about the advancements in these PhD level intelligences. I'm going to talk about O1 and we'll talk a little bit about O3, these new reasoning models and how they've rapidly broken some of these benchmarks that have been around for a while, like the ArcAGI benchmark. And the last one is looking at MatterGen and AlphaFold and GNOME, these approaches where we use AI to accelerate science. So we can actually do materials research or biology research. And this is so powerful because as AI accelerates those other fields, it in turn accelerates AI, or it accelerates AI research itself. So if you think the pace is going fast at the moment, I feel it. I think it's just going to get quicker and quicker. So it's very exciting. But those are some of the key areas, Ibs, that I'm seeing the this trajectory heading in. Maybe with that, what I'll do is I'll jump into our next session. So that's a little bit of a primer to get you excited about all these crazy technologies, but what does it mean for you and how can you apply it in an industry setting? So winding it right back, let's now spend a bit of time going into O1. So O1 is one of the new models from OpenAI, hosted on Azure OpenAI, and it's quite different to the models that have come before it. So the difference with this model is a little bit like the models today, foundation models like GPT-4o and other models. They are like quick, intuitive thinkers. You ask them a question and they just reply straight away. And they're very intelligent, but they don't always take the time to fully think through the problem or the question you've asked it. And it's a little bit like you might know some people who, you ask them a question and they weren't super listening, and sometimes they don't always give you the best answer. Whereas if we look at reasoning models like O1, reasoning models are like someone who you ask them a question and they take the time to think through the problem in their head. They mull it over, they attack the problem from different directions, and then they give you a really deliberate, well-considered response. And this is so powerful because it unlocks a wide range of what we call reasoning use cases. And whilst we might intuitively understand what the word reasoning means, when to apply it is not always clear. So the motivation for today, what I'd love to take you through is we've heard about these reasoning models. We're seeing the pace and acceleration in this area, but how do I know when to use O1 for a use case? And that's what we'll unpack today. But what I think is even better than jumping into those reasons, first, let's go and actually take a look at an application of one of these use cases. So in this tool, what we're going to do is look at a couple of scenarios, and you can apply this across any industry. The industry doesn't really matter. What we're trying to understand is the technology. But to anchor it, let's have a look at a retail example. So we'll start off here. In this scenario, so what we're going to do here is we're going to look at a retail scenario. So here we have, this is synthetic data. We've got Emily. She's calling a fashion retailer and she's asking to cancel her subscription to their loyalty program. She said the cost is too high and she wants out. And what we're doing here in this demo is we're comparing the responses of the two models to give us an intuition of where these reasoning scenarios can be really powerful. So on the left, you could see GPT-4o was streaming the result. Like I said before, it's responding straight away and it's streaming the results to us. On the right, if you saw, O1 was taking its time to first think about the problem before it came back and gave us a response. So it's taking the time to think through it. And let's have a little look at the differences in the responses. So GPT-4o, it said, maybe just as context too, there's a bunch of data that both models were given. So when Emily's calling up, it pulls all this data from her profile, things like, account information, purchase history, some of the customer service transcripts. You can think about multimodality as well, audio data, tabular data, unstructured data, and we'll talk more about that in a little moment. So it's got many different data sources that it's pulling from in order to get this answer. And GPT-4o comes back and says, hey, the prompt and the challenge to the model is to identify the core concern of the customer and then to draft a letter to say, hey, here's how we can make this right and try to retain the customer. So GPT-4o goes through it and identifies, financial concerns, looks at a spend, looks at a bunch of different things, and it says, okay, I can see you've got concerns about the cost. We're really sorry. We can offer you a bit of a discount or something like that. You could utilize some of the benefits we include and so on. So it anchors on that piece of information. But sometimes customers don't always tell us the actual reason. Well, I'm a customer too. Sometimes you don't always say the reason that you're upset or why you're actually canceling. So let's see if O1, which is a reasoning model, was able to pick out the real reason Emily was dissatisfied and address it. So what we see, if we're looking on the right now over here, what we can see is first, it gives us a summary here, but we'll skip it because we're going to go into the weeds. It can see that, hey, here's some of the information that O1 has found about it, the customer profile, about the purchase history. But the key thing that it identifies is this bit, the delayed delivery of the gown. And if I skip a little bit ahead, it can identify that this evening gown was critical for an event that Emily was attending, and despite assurances, the delivery was delayed, arriving after her event day. Now, this is fairly simple for a human, but let me show you why this is really, really powerful for a model to do. So if we have a look here, we can see in this call transcript, we can see this conversation here. And Emily was saying, hey, I'm calling about order, blah, blah, blah. I need this gown for an event on the weekend, and I just want to make sure it's going to be there in time. And the agent says, let me have a look. At this point in time, it looks like it's on track. No worries. But there's some clues in the data that you need to reason over in order to arrive at the right conclusion. So if we go up and have a look here in this other data set, we can see here, we can see that order that she made on the 22nd. And what can we see over here? We can see that if I scroll, we can see that the date that it was delivered was after the date. You can infer if she needed it that weekend, it was on the 25th. Clearly, this arrived after that time point. And this is something that humans can do. And now it's something that reasoning models can do. And if you have a look at the response from O1, it says, hi, Emily, ... It says, I understand that the timely delivery is crucial, especially when items are needed for special events. I noticed that your order, this evening gown and clutch bag, was delivered later than expected, which means it didn't arrive in time for your important event. We failed to meet your expectations, and for that, I'm truly sorry. So here, and then it talks about how can it make it right, and it addresses the concerns and tries to help improve that customer experience. The key thing here is looking at this reasoning. Yes, a human could also do this type of reasoning, but for a customer service agent who gets a phone call, gets a chat message, there's so much data and historical context about a customer, they don't have time to look through all of that data and reason over it to understand why that customer might be calling and what those pain points would be. So how powerful is it where you could use a reasoning model to help triage these types of concerns and identify the relationships and concerns in those data sets? I'll show one more example, and then we'll go into the weeds of the signs of a strong reasoning use case. So let's have a look at proactive maintenance, pretty common use case where we look at, hey, we've only got so much budget. Which of our assets in our fleet should we maintain? And similarly, in these two cases, we're basically given a range of transformers for a power company. And here, we're giving the model the task of identifying out of all of the transformers that we want to analyze, which ones should we prioritize the maintenance of? So in here, you can see again, O1 took a bit longer to think about the response before it comes back. Here we can see that both the models agree that this transformer, T1003, needs maintenance, but they differ on the second recommendation. And what's interesting is they give quite a good, if we look at GPT-4o, it gives quite a good analysis. It looks and calculates some of the, I don't even know some of these formulas were. We worked with some of our industry team to put it together. But but it goes through and it calculates and it does some stuff to work out whether there's thermal degradation and it needs some kind of maintenance. But O1, when it actually looks at the data, in the data set, some of the other clues that it's reasoning over are the load. So there's each transformer has a certain amount of load that it's rated for. So it says, I can only support this many MVA. And in here, it also has some, unstructured data and structured data, different reports from technicians, all this kind of stuff. And one of the data sets is a profile saying, hey, this transformer is supporting this industrial region. There's going to be this load, all these different customers using that transformer, drawing power from it. They're going to be drawing power from these different windows, and this is what it looks like. And there's a really key bit of information in here. You need to find what is the maximum power draw during these time windows to make sure it doesn't exceed the maximum draw that transformer can support. Otherwise, it will cause problems. And if you look at the responses from the two models, GPT-4o anchors on some of the clearer types of signals of things that need maintenance or some kind of attention or repair or switching out. Whereas on the right, O1 correctly identifies that, if I skip down to the other one, it correctly identifies that this load is going to exceed it due to the planned industrial park. So whilst you might not be a chemical engineer or electrical engineer, think about the use cases in your business where you have data that needs to be analyzed and thought about and reasoned over to arrive at some kind of conclusion. That's basically, I'm sure, every person on this call right now. So what are the data sets that you need these types of reasoning models to reason over? So given that framing and some of that background of how powerful this model can be, because I know if you just go and try and play with it in the playground, sometimes it's not always obvious why O1 is better. Because if you just say hello, the other model, both models are going to say hello back. It's not that different. So understanding that decision boundary when one is better than the other is really, really key. So let's go through and actually understand now, diving a level deeper. So this is for the techies in the audience. Let's have a look at the signs of a strong reasoning use case. So these signs are, the first one is the model needs to reason over many small data sets. And those data sets should ideally be from different modalities. They should be structured and unstructured. The second sign is the model needs to identify a set of steps to arrive at the correct answer. This one's probably not a surprise because it's trained on chains of thought, if you already know a little bit about O1. But something that involves intermediary steps, calculations, and so on to get to the right outcome. It's not just a one-step solution. And lastly, the problem should be sufficiently complex, and it doesn't have to be open-ended, but it's even better if it is open-ended. And to bring this to life, I'll walk us through a little case study and I'll call out when the model is using each of these features. So just as a bit of background, what I did was I took a case study from Boston Consulting Group. So this is what they used to interview people. It's one of their publicly available example case studies that they run applicants through. And in this case, we're looking at expanding a wine company from Australia to the US. And there's a few different products that could be taken to that market. Which one should we prioritize? So you can see here, that is an open-ended question, which is fairly complex. So already we're off to a good start. Next, it's got many, many different data sources. So there's 45 pages of tables and visuals and information. And all of this, needs to be ingested and reasoned over. So it's quite complex. So that's and I should also add that unstructured data in combination with structured data is something really powerful for O1. For example, we have many data-driven and machine learning models today that analyze billions of records of data, and O1 is not for that because O1 is a very large model and expensive. You don't want to use it for that. What you do want to do is continue to apply your existing models and data-driven rules to analyze your data, to say, find alerts. And when they're, and then generally when you have a system that generates alerts, someone has to go look at those alerts. So what about if you put O1 as the first level of triage, because it uses its reasoning and its world knowledge and its combination of unstructured and structured data to analyze those alerts beyond what just a data-driven system can do. And it can actually then triage and raise to the human expert, hey, out of these 100 alerts, these are the ones you really need to look at. Or out of these 45 pages of data, these are the key recommendations. What do you think? So the data is really, really key. And then the prompt given in this scenario was, hey, which products have the highest chance of being profitable and competitive? And there's some instructions that were provided to the model as well, just for context. And we also see here the response. So the response that was expected, it's got like an answer, is that the super premium wine product segment is the most competitive for the Australian producer to take to the US market. So that's the answer we're expecting from these two models. And what we can see in the results when we run this, so now that we've got a bit of an intuition, speed run of our understanding of reasoning models, what we can see here in the O1 response, O1 goes through and first calculates a bunch of intermediary artifacts. And what I mean by that is it identifies, first I need to find the total costs to build to manufacture the product. Then I need to find what the gross margin is. Then I need to work out the difference between the Australian and US market. It identifies the set of steps and the reasoning required to go from data to an answer. And this is where it really excels. It then goes on to draw conclusions, and it correctly identifies that the super premium market has the biggest difference between them. And I think there's some other factors as to why it's also the priority market. If we contrast that with GPT-4o's response, and I'll draw some of the, going a level deeper again, some of the reasons GPT-4o would struggle with this is because O1 has time, it has like a hidden scratch pad where it thinks and writes down its thoughts as it's going through the problem. Because it has time to go through the problem, it basically can calculate some of these, okay, I've got this data, let's calculate what the margin would be. And maybe it calculates some other intermediary data. So it goes off and tries an idea or a hypothesis. It calculates a bunch of stuff and it goes, that was a terrible idea. We shouldn't have done that. And it throws it away. And then it keeps going and gets to the right outcome. So you can see that the models step through and it has time to think through the problem. Here with GPT-4o, it's basically saying, hey, you need to give me the answer right now. And the model is in kind of like, if you like, a bit of a rush, and it doesn't have time to actually do those intermediary calculations in a hidden scratch pad. And then sometimes it makes mathematical mistakes. And you can see here on this slide, there's a number of calculation errors, which leads it to get to the wrong conclusion. So you can see in this example as well, O1 performed really well. And the reasons for it were those three signs. It involves many different data sets that have to be reasoned over. It had to develop a strategy to get to that outcome. And also it needed to, until blank on the third one, it was a sufficiently complex and open-ended problem, which allows it to be differentiated. Very quickly, some people might ask, this is my own view, this is a Microsoft view, but might ask, well, what about GPT-4o with some kind of chain of thought or a reasoning framework? And that's true. You can sort of bootstrap around these models a reasoning framework to give it a little scratch pad and do this kind of stuff. There's kind of two main thoughts about this, which is the reasoning or the steps required the same every time? If so, you could do that. And does it warrant the investment to go off and do that? So there's two parts in there. If you're in a regulated industry and you've got a very predetermined process, maybe you want the O1 to give you the recommendations, but you might want to put that scaffolding in to sort of constrain it. But also thinking about how long it takes to build these scaffolds. In the top example here, you can see building the foundation model. You then need to spend maybe 4 weeks of development building this reasoning framework around it to get to business value. Whereas if you just start with O1 to prove out your reasoning use case, You can then later decide if you want to optimize it and put constraints around it, you could. But starting with O1 lets you get to value quicker, and you don't need to build all of that, because O1 has been specially trained for, hundreds, thousands, millions of hours in order to achieve those tasks. And the other reason that I think, because this is a very common question I get, the other reason I think it's really, not live demo, we did that. The other reason I think it's really important is the pace at which this is moving. So O3, you might have seen in December, I think they announced the benchmarks and so on from the model. O3 obviously being the success of O1. Kind of amusingly, they said it wasn't called O2 because there's a telco in Europe that's called O2, so they skipped one. So that's why it's O3. But you can see here, this graph on the left, this is the ARC AGI benchmark. And that's a benchmark back to 2019 that, or I think actually even earlier, that has not been, it was notoriously very difficult for models to do. And you can see, look at the rate of progress on this benchmark from GPT-4o to O1, a reasoning model, to O3, almost completely solving it, where human capability was ranked at about 65%, I think, on this benchmark. I think 80 was kind of the conservative benchmark of human performance. You can also see Sam Altman, some of the tweets, because apparently that's how industry news is delivered these days. You can see here that they're talking about O3 coming out, O3 Mini in a few weeks, so imminently. And you can also see this was announced, like a closed door meeting talking about PhD level super agents. So this space is moving. Amusingly, after this, he also did send a tweet saying, don't get too excited. He's trying to wind back some of the excitement. But regardless, the amount of progress and pace in this area is just insane. And if you're, like, I understand why it's sometimes not clear what's O1, what's so different with the other models. I just put in prompts and they seem similar. If you're not experimenting and working with reasoning models, I really encourage you to take the time to go across your business. Where could they have an impact? Because the pace is not stopping, and you need to be ready to use and adopt them as they continue to be released. So super exciting. With that, I'm going to hand over to Rafael, who's going to be talking to us about agentic AI, another very exciting topic. So over to you, Raf. I'll let you take the screen.
Excellent. Thanks, Luca. We've learned so far quite a lot about the reasoning models, and we know that's one of the applications for the reasoning models, definitely with the complexity of the tasks. And these models will find its way very nicely into more sophisticated systems. And these systems are really the we can see, back in the day, we've had one-to-one connections, and now we are moving more into like a multi-agent systems. So I'm going to start my presentation with this quote, which is, I think, is quite important, and is very strong, coming from Bill Gates, who is a father of Windows, and bringing us from really the command line into visual interface. So Bill Gates is not the only one. We know that other leaders are literally raving about how important this shift is towards the multi-agents. And the reason for that is very, very simple. What is really happening, with the same time how we automate manufacturing industry, we are now entering and bringing systems which are not just working as a companion to humans, that we can, with them, they can work along us. So if you imagine industry back in the day, we've had humans operators. Now we've got some of the parts of the system being fully automated, in some parts not. So this shift is very, very important, because right now we are interacting still. COVID actually helped us to go more into this digital age, and with a shift to the agents, we're definitely gonna see that our co-worker might not necessarily be a human. So what are the agents, and why is such a big hype? And look, there are many different definitions. In a very simple way, we can say that agent is simply some form of microservice which's got some AI built in and can work autonomously. So this is a huge difference than what we've had in the past. So again, agent can but doesn't have to, and this is the beauty of the entire solution. So the agent can take actions, has some form of the memory, planning, orchestration, so it can orchestrate other agents, but also can be orchestrated by or the more superior agents. And this is where it's really cool. This is where the models are really not equal. And this is really important when we're picking a model for the agent, for the agent to perform in a top performance. And obviously agents can be interactive and event driven, so they can work over hours, days or weeks, and they don't have to solve the task right away. They also can work asynchronously, which is super fascinating. So multi-trillion-dollar opportunity, and how we actually, what's really happened and why all of a sudden we went from bots to more sophisticated copilots and then to AI agents. And probably at this point we can just picture this scenario. Your assistant knows to open an umbrella when it rains, right? And how bot will tackle this task, how copilot will tackle this task, and how agent. That's pretty straightforward if you know that's the rain will rain, right? But what if the environment changes? How each of them will tackle the same problem? So what if the changes in the weather gets extremely sunny, or we will have a snow, right? So a bot will not able to action on this scenario at all because it will not be programmed to do so. Copilot might have some AI built in. However, Copilot, the way how the Copilot are structured, it will come back to the user or the human and will ask, okay, I think this is what is happening. What would you like to do, right? Where the agent who is fully autonomous can actually make an action, judgment and action. And again, agents, I want to just state this very, what is really important, agents can do both. And this is it depends on your scenario, and it really depends how you configure them. So it's just an evolution to what we've done in the past. And there are many different use cases and the benefits to going towards the AI agent solution. So if we look on the agents, so agents can be really personal, so one-to-one connection, and the agent can work for the user themselves. The agent can be more organizational, so work across within one organization, can have some sense of the business processes, and also can be can work across the different organizations. So we can have one organization with a set of agents and another set of the organization with another set of agents. They can communicate with each other at the same time, communicate with humans. So this is really where the corporations, the way how we configure them, the way how we make the APIs and systems interact, this can be mix and match in various different applications. So how we got there? I mean, we got there in a pretty interesting way. So we really started with robotic processes automation, more as a role-based bots and agents. Then we moved towards a traditional ML and RL, so reinforced learning, where we went through the phases of the try and error, and then we slowly entered the Gen AI. So Gen AI phase, this is where we all get super exciting about the text-driven and dictionary-driven large language models. And we transition we had no time, but we transition into this multimodalities, and multimodalities are this another huge topic, which we literally scratch the surface. So we've got a vision and voice and any other parts of it. But so far, up to this point, so this is where we are at the moment. So far, we really work in a context of the AI form assistant, right? So this is one-to-one. We had the assistants, co-pilots, and they were just working with us, right? But now we are moving into more AI team, a team of the agents, which they can work with each other, but they can work along us. So this is a huge leap, because we can solve more complex problems. This is where we are going from this, chatbot approach to really find the value in applying an AI and helping us automate a bigger chunks of the tasks. And obviously the future, this is really exciting where we're going with this thing. At the moment, we are at the stage when we can create these agents, we can configure them. But hopefully in the future, and we know that, with stuff, what Luca just mentioned, O3 models, this one which can look outside of the context, they can actually replicate and create an agent and fly. They can create the agents which you don't have in your portfolio, but there's a need because the task came from somewhere. So it's a really exciting space, and this is a huge revolution. This is no longer, we are not talking about the text assistants, human doing majority of the work. We're actually entering the AI teamwork. So agent can work on a very simple tasks. Again, the scope of the agent is entirely up to us, how complex we wanna make. At the moment, we've got a tech. And we know that because myself and Luca and other, very skilled engineers in Microsoft, we actually spent last probably at least 8 months playing with alpha versions of some of the solutions, and we built MVPs internally. And we know that's where you can configure these agents from a very simple tasks, going to the tasks which are more constrained with a different business processes and rules. So they won't just go wild. We can really log them in and just say, hey, follow these procedures, to being very dynamic. And look, this dynamic approach is also very useful when, if, let's say, a complexity of the, tasks might not necessarily be that important, right? So there are definitely unlimited use cases, as you can imagine. So wherever we can put humans, and we can create the teams, and anywhere in the white collar industry, I can see as there's lots of processes we do in these industries, in these teams, which could be handled by AI agent. So we pretty much is unlimited. Sky is the limit, really. And where the technology is going, I just see this. We're going to be able to tackle more and more complex tasks. What is really important, we have to really get into this space, because this is just accelerating. So, as I mentioned this previously, we obviously we've looked into the agents in a different complexities and setups. So again, agents can be in the form of the chatbot. So this could be user, this still can operate as some form of the assistant. That's the level 1 agent. Level 2 of the agent, it can work in between humans. So it can have some human supervisor, the supervisor which, let's say, will sanitize some form of the output from the agent and interact with some end user. So agent is doing the hard work. Supervisor is supervising and approving the work, and the output is going straight to the user. So again, you can configure this as you like. And then it's obviously this very complex scenario where I think more and more of us, we're gonna lean towards in the future, where some of the business processes, they can have the agents working in every department along the humans. The agents and humans can collaborate, and we can have a supervisors either in every department, or this could be centralized supervisor, and they can interact with other humans, right? So it's definitely all of this, why we're doing this in the first place, where you can think, wow, this is huge, right? And we are doing because we always wanted to improve. We always wanted to, hit our targets. We always want to optimize the processes. There are lots of processes which, humans do right now, which, they can be boring, draining, and we've got a huge staff turnover. So in these situations, some of the agents can literally do the grunt work and the heavy task, this one which will require really in-depth reasoning, we can, hand over to humans. So right now, in Microsoft, we've actually got everything what you need to start from the from the very simplistic agents. So this is where we're looking on the Copilot agents, almost at the front. And when you go to the Copilot, you see you can create a very simplistic low-code agent, and the cool, this is one-to-one connection. This form of the agent doesn't have any form of the orchestrations. I'm going to expand on the orchestrations really soon. And then we are jumping towards the Copilot Studio. So Copilot Studio, Satya actually on one of his talks said, is very easy. And it is very easy. It's almost so you get click, and you've got your agent set up. So the UI and the way how we structure, we give lots of flexibility. And I'm going to slightly expand on this topic in the next slides. And obviously, as always, we've got Azure AI Foundry. So we've got AI Foundry with a Pro Code solution. And this Pro Code solution it says Pro Code, but the complexity of this microservices is actually not too bad. Myself and Luca, we work with these things. We've built complex SaaS applications already, and this is not much more to what we've been doing for the long time. It's really something what actually you can mix and match. So, but you've got all of the tools given. So, low-code solution. So as I mentioned, you can jump into the Copilot. It says Copilot Studio, but this is only a small part of the Copilot Studio. This is really a minified version of what the Copilot Studio actually gives you. This is more, let's say, for the individuals, and they can create their own form of a very lightweight Copilots. And this is quite easy. That's the steps. You just go to work. You can go and create the Copilot. Pretty straightforward. Second one, which has been working recently, I think we already got this in beta, or we've released it. We've got the actions. So these actions is something what even OpenAI only I think last week released some form of tasks. So this is just another way of looking of the automating some of the systems, and they've got some form of AI built in as well. And this is really, again, these actions, they here even says it in a preview, they give you some form of automation and of your processes. Low-code solution, this is what I've mentioned, what we've got in a Copilot Studio. Click, you've got your agent, you pick your model from the model catalog, and there are multiple models to choose from. And what is interesting in this solution, you can actually create these agents and you can integrate into, let's say, Teams. You can integrate this into Copilot. You can integrate this into your system of your choice. You can tap into functions as well and hooks. So they can perform some actions on their file system. It's quite interesting. And, they've got some level of the orchestration, and we say it's action-based orchestrations, but I wouldn't be that excited about the orchestrations. It's still more tailored towards the one-to-one task solving solution. They're really cool, and you can go quite advanced up to some point. As always with the interfaces which are pre-designed, there are always some limits, right? And these limits, if you can overcome if you're going to the Pro Code solution. So the Pro Code solution is really where where we see absolute flexibility of how you want to program the agent. So this is just an example, right? Procode solution is really, I would say, designed to really take this to the next level, to have the concept of the specialized agents, have the concept of the orchestrator and different team members. So who is our orchestrator? And our orchestrator, you can think about the orchestrator as some form of director or a manager. So this orchestrator it's got some broad knowledge about the task and about the team. So he will have to analyze the both end of the spectrum and will have to pick the best team for the job. The orchestrator can also plan how this work should happen, the stages and everything else. So it's really as someone, when you look on a human team, it's someone who can organize and can schedule and can evaluate if the task can be done by this team altogether. So this is just a proposal. Here we said, okay, why not? An orchestrator should have a really good reasoning model, because we want them to be able to analyze in depth this complex task and then descending to the smaller agents. And again, you can mix and match models as well. So here I just said, okay, all of them is going to just run on the 4.0, but they don't have to. You can pick any model you like. Some of them are better to run the small models. And when you go to this side, obviously, this is where it's quite important to actually think that you, when you create this very specific agents, it's always better to use some more specialized models, specialized trained models. So because these agents, they're gonna do in and out some tasks, and you want them to perform quickly, and you want them to perform well, right? So they don't have to have the whole scope of the information. They need to just know very, very well what they're doing. Same as humans. You want to have a specialist in an area which is very good at doing his job, and this is what was super exciting. So specialized models equals better agents. To help you with this task, obviously Microsoft, we've released a number of different frameworks which will help you to mix and match actions and agents, and they've got pros and cons. So some of them, they're open source as well. So you can literally grab them, start using them. We've tested all of them, so we know the strengths and weaknesses of these frameworks. And look, I've got a demo for you, which we mainly focus on the AutoGen, which is quite interesting framework. But there are also other frameworks that are popping out, like they're everywhere, right? So, but we always recommend to use the tools which we know and we tested and we know they're secure in the first place. And so yeah, these they've got different capabilities, but lots of these capabilities, if you look on the chips here below, they're very, very similar. So when you should use multi-agent systems over a single agent, it's very simple what I said. If you've got a large task and you think this task cannot be solved by the single agent, you want to slice and dice this task. If you've got a task which you think could be done asynchronously, and you don't want to just stuff up the one agent and load them with one task, and he will not going to be able to do anything else. This is where you want to slice this big chunk of work. And the same like with a team, right? If you've got one staff or 4 staff, is always better just to knowing that they work at the same time at the different piece of the puzzle. And when we just look on this chart here, which we've done lots of evaluations, metrics, and calculating the accuracy, and these are huge leap from the single agent solutions to the multi one. So it's definitely, this is this is the area, and this is where we are moving, right? So let's look on this example, which myself and Luca we've prepared, and probably some of you had a opportunity to see at one of our workshops. So we've created some form of business units. So this is some imaginary workplace. We've got the different business units, and within this business units, we can see that we've got a human and we've got an agent, and we've got some form of functions and a knowledge, so they can really interact with each other. So at any point of time, the teams are constructed with a, and this is just for the visual purpose. This could be 5 humans and 1 agent. It could be 4 agents and 1 human. So the opportunities are endless, really. And then once they've solve some of the problems, or once they communicate, they can communicate back to the base. So they're like a pod. This could be filtered and pushed further to and work with the customers or the employees. It's going to be form of the supervisor, which supervises some of the outputs, but doesn't have to be as well. So configurations here of this solution are really endless, and it will change. So some of the business units could be more automated than others, and some of them less. So and some of the agents, the weight of this agent could be different as well. So we can have an agent who just perform a very small task, and it's fine. And then other agent could be really, really complex and can solve big chunk of work. So it's a maximum flexibility. So we are seeing a huge momentum, around Asia. And we know that's the interest is just keep increasing, because this is where this is the huge industry shift. Not a while ago, I've attended Microsoft AI tour, and one of the talks was about the agents, and I could see in my own eyes, and evaluate how many of you are so interested with this shift, right? This is much more exciting than the chatbots. We've had the chatbots, and they're really helping us, but this is like changing the industry on its own. So, and we are here to help you with your next implementations as well. So just within the Microsoft itself, when we look on the stats, I mean, the numbers talk by themselves. So we know that we've experienced 150 million interactions annually, and this agents served for 1 billion customers. And we've got probably around 10,000 agents running around. So that's massive, right? And we know that's we've got 12 to 16% of resolved cases, and a reduction in handle time for these chat cases. 9 to 12% increase in cases and chats managed by support agents, and also 30% decrease in agents requiring peer assistance to resolve the case. How fascinating. 30% decrease. So these agents can also evolve and can learn and improve, in a matter of time. So Azure Foundry, we've got pretty much everything right now for the developing the modern solutions. You can bring your own stack. We've got extensive catalog of tools which you can use, and you can make these agents super successful. And we've got a huge catalog of different models. So again, we focus our talks about the OpenAI. You don't have to. If you've got a preference of using different models, we've got that too. And these agents will also work with any model. As I mentioned previously, you can start with probably, this is where I'm focusing really on the solution, which is more advanced. So you can start with a Copilot Studio, and you can set up your agent, because it's let's say simpler click solution. and you can bring some of the services from the Azure AI Foundry, and that's fine. And then once you learn, you can progress. You can also do other way. So you can start with a pro code, which I personally think is not that complex. If it's not a magic, right? You can start with that thing and also integrate Copilot Studio backwards to some of the things. So again, your agent, the way what this agent do can utilize service from the Copilot Studio, and just having that front fascia or some of the other functions from the pro code solution, and this is where you are gaining the full orchestration and so on and so forth. We also got obviously a growing ecosystem of the certified connectors. You can reuse your own APIs, and and endless possibilities of developing the larger systems in the future. And just a closing release slide. And when you use our services, your data is being protected. Your usage can be monitored, and you can scale, because we are scaling with you as well. We are always ahead of the game, and there is no danger that anything what you've built will not scale, because we are scaling with you. We are always ahead of the game. So what we're gonna do, I think this is enough said. I would like to show you some interesting demo I've got. And in this demo, I've got a demo which we've built with Luca, and they're called agents in a box. Okay, so this is one of the use cases we've built and tested, and you can see this use case is actually running on the 4.0. This is just for us to understand how the agents communicate with each other. So we try this on multiple different use cases. For the purpose of this demo, I'm just gonna onboard Luca. So I'm gonna start my task with sending some form of the task to the agents. Obviously, this one is not very complex, but it's very broad. But this is just to prove the point. So I'm running a task and I'm sending to the AI agent. So see what is happening. Okay, so the task being created. So what is really happening? The task being picked up by a planner. So the planner, let's say we call this planner, is some form of orchestrator who just said, okay, I've got a portfolio, I've got this team of the agents, and this is the task. So what I'm supposed to do? So he had to understand, task itself. He had to understand what I am trying to do and which steps are required, and if he's got, a team to do so. In this task, obviously we've got the stages, so we've got different stages. These stages can vary. They're fully dynamic, and in the stages, as a human, so we put the human in the loop here, by the way, to approve all of these things. We can run this task fully autonomously, but if I do so, actually I'm gonna do it. So let's say we could automate the system and just click all of the stages, right? So as a human, I just literally screen this, and all this task being now approved, right? So what is happening here? This task went through the AIs, and they've obviously this has been really accelerated just for the purpose of the demo. They went and solved this task completely by themselves, and you can see based only on this chart, they have a conversation. They went through the different stages, and they solved the task. I'm going to run the same task here, and going as a human, going step by step. So I said, okay, I'm happy with this stage. Let's see what is happening. So I approved the first stage. This stage went to the HR agent. HR agent pick up the stage, and this is something what is actually really interesting. I'm just going to quickly mention here. We have actually implemented something what we called a manager in a loop as well, which is quite interesting because exactly the same how we've got the human teams. Sometimes we need teams are led by some form of leads or managers, and they can filter the information which is happening, which are coming from the agents themselves, because they can be very chatty as well. So same how we've got in a normal team, this guy here can filter all of this information, only output to the human what is really important. So can work with agents just to be I don't know, scrum master or a manager, and just make sure I'm gonna really take this information further. So I can go here. I can skip this stage because I think it's irrelevant, and I can go through all of the stages. So once I go with all of these things, we can see the task being slowly solved, and they're trying to adapt as well. What we also implemented here, which probably is not in this scenario, this plan can change as well. So this could be some factors which, because obviously there are humans involved here as well. There could be some delays. There could be some changes to the task itself. So the human could add changes to the task. This plan can adapt as we go. It's almost like going when we've got a GPS and we're going from the location 1 to B, and all of a sudden we've got some road work, and we have to redirect or change and adapt. So this whole scenario is fully dynamic. So as you can tell, this is just an example how the task look like on the from this side of it. You can think about this, that this is some form of agent console. Just we did this to more visualize how the system could work. Obviously, these systems could be completely different, and the really important part is here, how the agents themselves their work and operate at the different stages of the task. And this task, could be completely dynamic.
All right. Thank you, Luca, and thank you, Rafael. So that was an awesome set of content over there that we covered around, again, both our reasoning model and around agents as well. Just holding up here while my slides come back up. So folks, again, thank you, everyone. I know that we've run a little bit over time, but again, we've covered quite a bit of content today, and we hope that you enjoyed the content that we had again today. What I would encourage everybody to do as a next step, there's a few things that you can do. Number one, go explore some of the OpenAI services that we talked about today. I encourage you to go on Microsoft Learn to learn a little bit more as well about some of the topics that we covered today. Number three, go on YouTube, right? So we have a channel on YouTube where we cover a lot of these topics in a lot more detail as well. And then go start building on AI Foundry. That's a great place for you to experiment with a lot of these new skills as well. Now, folks, again, this is episode 1. We've got a lot more content that we want to cover in future episodes as well. Hopefully you enjoyed it. Hopefully you found it very useful. And we look forward to seeing all of you in episode 2 of AI Horizons. Thank you, everyone, and enjoy the rest of your day.